Hello and welcome. In today's class, we'll be looking at RF power divider, or what we'll call an RF power combiner. And we see different types that we have in RF lab, and also we look at their characteristics, meaning in terms of amplitude, phase, and losses, both return loss and insertion loss. So welcome to the class. First thing I will first like to show is the hardware, the power divider themselves. We have different types. There are 2 ways, 4 ways, 8 ways, and up to even 16 ways. So, but I have few ones here with me. I would like that we first look at the hardware. So the first one here we have a device here, and here we have, this is the input part. So when you are sending a signal from here and you are taking to output here, so this we call a power divider, because only one is coming and is split into 2 parts. In such situation as this one, we will have a schematic diagram that looks like this. We have something like this. So this is input, and here we have output. So we have 1 input going and 2 are taken. So this one, regarding the one I've just shown, so this is one. Another one is this one is similar to that one, and here you can see it says a power divider, and the frequency range is from 0.5 to 6, and this is 2S1, so it means it's two output and 1 input. 2 output and 1 input if you are using it as a divider, and if you are using it as a combiner, you have 2 input and you are taking 1 output. So this is it. Also here, another one is this one, which we have 4 output. So you can see it's already said it. It's already indicated here, and the power rating is 30 watt. So 30 watt, this is a very good one. And we have 1 input power. So this is input port, sorry, and this is a very good power divider. This is one example also. Another type is this one, but I think manufacturer stopped making this particular one now. So for no reason, but I don't know, but they've stopped making this particular one. So this has been for a very long time, and it says its power frequency range is from 2.4 to 6 gigahertz. 2.4 to 6 gigahertz. Okay. So there are different types of them, and also depending on the requirement of the customer. So the designers will divide based on the requirement of customer. So here we have another one which is from 0.5 to 6 gigahertz, but in this particular situation, this is 20 watt. This is 20 watt. So you can see how it looks. So it's also 1 input and you take 2 output. So this is a T-junction power divider. Very good. Also here we have another power divider. Here is already indicating, even here is saying it, this is in. So this directly is a power divider, 2-way power divider. So signal is coming through here, and you are taking 2 output. You are taking 2 output. Okay. Another one is this one that has 8 output. That's a very big one, 8 output. So you can see how just 1 signal is coming, and they are all splitting to 8 parts. So one important thing that we have to take note with this power divider is that, or let's say a question that usually comes from students is that, what is the effect of do we have amplitude distortion in the signal when we send signal from one port and we are taking out from output, uh, output? Our easy answer, or one single answer, is that no. They keep same power amplitude, and I will show you how they keep power amplitude. So they have all signals that are coming from the output will keep similar amplitude, and there will be no amplitude degradation. Okay. Yes, and also when you are using them as combiner as well, so you put all your input here and you take output at the end. Okay, so but the major drawback, okay, let's first look at the characteristics. So characteristics for power divider or power combiner, number one is that they keep same signal amplitude. So they keep same signal per amplitude. Also, another thing is that they have 0-degree phase relationship. This is very important relationship. Yeah. Okay. And then third thing is that they keep high isolation. They keep high isolation between output. So meaning that signal will not leak from either of the ports to each other. So if you send signal here, different signal will go here and different signal will go here. Okay, that is that. And another thing is return loss, insertion loss. So insertion loss of different values depending on the number of outputs. Okay, sorry for my writing. Okay, so the insertion loss, and what we mean by insertion loss is the energy loss when a signal is moving from one particular point to another in a transmission line. So you can see here we have signal going directly from here into here. So as it goes through the device, it's losing some energy, and that is what we mean by insertion loss. And by that, I have came up with one graph to show you the relationship. So here I have my graph of output port versus insertion loss in dB. So insertion loss is in dB because most of our signal in RF lab are always measured in dB. We have mentioned that in the previous class. Okay, and here you can see this is number of output ports. So we have here, whenever you have two ports, your insertion loss value will be like 3 dB, and when you have 3 ports, your insertion loss dB value will be around 4.8. This is theoretical anyway. It could be different in your own case, depending also on so many factors as well. In case you have like 4 ports, you have theoretical insertion loss of 6 dB, and when you have 5 ports output, you'll be having like 7.0 insertion loss dB, and it goes on like that until 12. So let's say 12, if you have 12 output, just like the case we have 8 ports. So we have 8 ports, and we believe that our insertion loss will be around this range. So in case where you have like 12 output, your insertion loss will be around 10.8. So you need to take note of this one, very important. So whenever you are measuring signal, you should know that you are going to lose some signal, and those should be taken into account. So when you measure your signal, let's say you are supposed to measure like 22.0 dB, and you are measuring like 10.2 dB, so you should know that this 10.8 somewhere is somewhere, so it has to be considered in your measurement. So take note of this one, is very important. Okay, so this is the simple thing, the short video I wanted to show you, those power combiner and power divider. In case you have any question, please feel free to send me a message or just put your comment in the comment part of the video. And if you have any more requests on what next you want me to show on in the RF lab, please let me know. Do not hesitate to send message to me. Have a good day. Bye bye.